Let's go to the oddball. Oh shoot, I shouldn't say oddball. It's the even ball. What? What am I even talking about? All right, I should really plan these things out before I do them. There's that silly table, huh? There's that table, and I wrote cosine in. But I wrote in y equals cosine of x. So I want to just show some stuff about it. Cosine is an even function. Cosine is. Its inverse is not. Cosine is an even function. Its inverse is not, which means you can't say really shit about it. Cosine, look, notice, even means symmetric about the y-axis. All right, I know my graph sucks, but in theory, it would be symmetric if you folded it across. All right, the actual graph, not written by this guy, would look just fine. But we're only going to look at maybe this portion here, huh? There's our cosine function. That is not the inverse function. That's the cosine function. I just want to kind of show why some things are going to happen. All right, let's move back into it. Let's look at our function. Let's look at a function where it's equal to cosine inverse of x, or arc cosine. So let's look. Let's say, all right, cosine inverse of, and you put ratios inside. All the stuff in blue in here, that's what you can pop inside. So let's look at the cosine inverse of 1. And you can see that it pops out 0. Now, cosine inverse, keep warning, it's the dangerous one. It just doesn't behave quite right. So let me write them in a few times. You know where we're going. We're just going to fill this out. So you can't say I never showed you or didn't try to. And then we're going to put in our root 3 over 2 or root 2 over 2 or 1/2. And we just look over and we're like, well, dude, I mean, it's just like root 3 over 2. And you mean pi over 6. Let's go. You talking about root 2 over 2? That's pi over 4. Cosine inverse of root 2 over 2 is pi over 4. Cosine inverse of 1/2, let's go, it's just pi over 3. And then lastly, the one that doesn't, it's just the cosine inverse of what goes inside there? 0 is equal to pi over 2. Let's show you what's going to happen here. Let's try the same thing. Okay. Cosine inverse of, cosine inverse of, cosine inverse of, and we only need to do 4 because we don't need to do 0. All right, so let's pop in -1. Cosine inverse of -1. Cosine inverse of -1. Cosine inverse. It's popping out the x value. Oh, remember we're swapping our inputs with our outputs. That's equal to pi. That angle is pi. Does not behave like the rest. Let's look at negative root 3 over 2. Negative root 3 over 2 would be about right here. Go over here and like, shit, it's somewhere. It's somewhere in between pi over 2 and pi. If I could only figure out what it could possibly be. Now, I'm not going to even explain why I was going to write it in. 5 pi over 6. 5 pi over 6. Maybe I will explain it. A is the angle in the second quadrant that has the same reference angle as the positive. Cosine inverse of root 3 over 2 is pi over 6. So cosine inverse of negative root 3 over 2, well, it's something pi over 6. You just got to figure out which one's in the second quadrant. So maybe drawing it in this way, going, dude, got a reference angle of pi over 6. What's the angle? Frickin' 5 pi over 6. Let's play the same game to the next one. Like, all right, cool. We're going to go look at negative root 2 over 2. Negative root 2 over 2. So did I write pi over 2 back here? I am so sorry. That's pi over 4. Sorry Ha! Can't get extra credit for that shit. I caught it. Damn, that took me way too long to catch that. So we're going to have the same reference angle, a pi over 4, but we're over in the second quadrant. And again, isn't it go ASTC, like all students take calculus, all students take cash? So it's only all of them are positive in the first, but only sine is positive in the second because cosine is negative. That's the inputs are negative over in the second quadrant, and that's why we're going to pop out angles over there. Because this is where the y values or the x value. Never mind. I'm confusing myself. I'll shut up at this point. Just keep watching the pattern. So your answer here is going to be 3 pi over 4, because your reference angle is pi over 4. What has a reference angle of pi over 4? 3 pi over 4. We go to the next one. We're like, hey, cosine inverse of -1/2. Well, we already know our reference angle. Oops. We already know our reference angle. It's some sort of pi over 3. We only have to figure out what pi over 3 it is in the second quadrant. And that is 2 pi over 3. We go to our last one. Oh, there isn't a last one. We've actually nailed them all. So you have now seen, I've gone through and I've given you all the different common angles and the ratios that go with them. You swap your inputs with your outputs, and cosine inverse does not behave nicely. It does not. It's the tricky one. Tangent inverse, sine inverse, they're dope. They're dope. That's the good stuff. But be careful. Be careful. So I'll come back with some new games. Maybe a worksheet. Maybe a quiz. I don't know. I'll see you